Greetings, I'm the Astro 30 here again, and today I want to test out how well this, it's actually pronounced haiku. I could hear all the Japanese people that may have watched the previous video cringe every time I said haku, or heiko, whatever I said. It's haku. How good this soldering iron is actually at, well, soldering. So what I'm going to do is I'm going to assemble this STK4191 stereo amplifier kit and see how well the soldering iron works. So because they've packed everything together in this kit, I have no idea. Oh, they actually supply knobs. I didn't know it came with knobs. Nice. I have no idea what parts go with what, but I assume those filter caps go with this. These IC sockets go with that because there's one, two, well, there's only 2 op amps on the board, so obviously the potentiometers go with it and the capacitors go with it, but I seem to be missing resistors. So there's resistors there, so I don't know which ones go with what project, you see. So I'm sort of like playing it by ear, but anyway, I'm going to assemble all the resistors on this circuit board. Oh, sorry, there's only 2 IC sockets and 2 ICs, obviously. So what I might do is I might start with those IC sockets because they're just convenient right there. So I'm just going to place them in the board where they go. One there, putting the notch the same way around as the notch on the PCB. Okay, now let's see how well this solders. Probably not as great as my normal soldering iron. It does take quite a fair bit longer to get a good decent joint, but it appears that it is doing what it is supposed to do, which is solder. So come on, there we go. Yeah, it's soldering. I'm probably not going to assemble the whole thing today, so it'll be, this video once it's published will be complete and up to the testing stage and seeing how well this thing actually works. But for now, all I'm going to do is probably solder in resistors and really put this soldering iron through its paces just to see how good it actually is, because I don't think it's anywhere near 360 degrees where I've set it. Yeah, it's basically reminding me of the days of when I had a 15-watt soldering iron. So if we take a look at my enormous, if we take a look at the circuit board here, we can see that the joints aren't all that bad. So yeah, so I'll just move on to resistors and come back if I've got any little bit of issues anywhere, and yeah, we'll go from there. I just realised I probably should have soldered those IC sockets in after the resistors because, well, the IC socket's height is higher than the body of the resistors, obviously. So I'm just using a pencil to prop the resistors up when I'm soldering them. But the soldering iron appears to be, well, working, so I'm relatively happy. Oops, I missed a pin there. That's alright. I can fix that now. But yeah, it is working as a soldering iron. I mean, for what I paid for it. I don't think it's going to replace my Digitech, but is it Digitech? Duratech rather. But yeah, it's okay. It can sit on the bench or the table. Anyway, continuing on. Now, as I was assembling this, I noticed there's some 1 watt resistors. I think they're supposed to be 1 watt. And over here, there's two 1 kilo ohm. Let me turn it the right way up for you. Two 1 kilo ohm resistors here. Now, one of these, I believe it's this one at the bottom, goes off to the negative portion of the 4700 microfarad capacitor on the negative side of the bridge rectifier. And if I now follow the positive here, where are we? Goes all the way around here to, well, it goes to the bottom one, so the top one was the negative, but these two then go off over to these two 1 watt 15 volt xenodiodes. So these really should be 1 watt. If we were using 1 watt xenodiodes here and having 1 kilo ohm dropper resistors there, and then we're forming the positive and negative rails for the two op amps off of there, they should be 1 watt. So I'm going to have to probably go out to the electronics store, buy two 1 watt resistors, and probably two 15 volt 1 watt xenodiodes, because they don't appear to be anywhere either. I can't see them. They're not in this packet of components. They're not in this bag of capacitors here, because the kit itself, there's two kits in one packet, so I don't know what parts go with what. And if so, where are all the parts for this? All I've got for the clock is the LEDs, so half the parts are missing. So I'm not entirely happy, because now I've got what I paid $30 for with a broken display board and this control board. It's missing half the parts. Although, if I look properly before I start blaming people, I'm going to blame them anyway, because, well, yeah, this is just bad. There is more bags of components in here, so I reckon some of these are for the clock. But okay, well, the parts for the clock are there, and, well, those look like the diodes for the bridge rectifier and the two xenodiodes, so I've got them at least. And the rest of these must be for the clock, so all these parts I've got left over for the clock. But I really wish they had packed it all separately, so I don't have to go, oh, where the hell is the part for this, and where is the hell's the part for that? And, you know, spend half my time getting frustrated and pissed off because I can't find things. Like, for example, there's a Ziploc bag left over from the Haku soldering iron kit. Just boom, 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 boom. That's supposed to be a microprocessor, and it's not even in anti-static foam. That's brilliant, guys. Very brilliant. And, you know, just do that, and there you go. There's all the parts necessary for, well, the semiconductors at least, and a few capacitors and resistors for the clock. You know, how hard was that? Oh, but no, we have to make you work through and figure out what component goes for what thing, and oh, it's just a nightmare. So if you order one of these power amplifier kits from that Sri Lankan supplier on eBay, don't order another kit from the same supplier at the same time, because you'll end up with a mess of components and not know what goes where. I found the xenodiodes, but I'm still needing some 1 watt 1K resistors. Now that's a 1N4744, which from memory I do believe is a 1 watt Xeno. So actually there is a parts list to this, so we'll have a look at my enormous, have a look at what we've got here. Does it even mention? No, it just says 15 volt. Check this out. 15 volt Zener 1 watt 2. But it doesn't actually give me what the actual part number is, but the silicon diode should be 1N5392. So if I double check what they are, if I can get them out the bag, 1N5392, which is what it's supposed to be. 5392, yep. So these were 1N4744. So I'm just going to look up what that is. I was right, a 1N4744A is a 1 watt 15 volt Zener. So at least they got that correct. So anyway, I'm going to be continuing on with soldering components. I'm going to leave these 1Ks out and go get some 1 watt resistors. I've got to go out anyway. So I'll just continue on soldering in the rest of the resistors. Okay, I have got all the resistors bar 6 installed, and I'll tell you why in a minute. 2 are obvious. I'm going to be replacing these 2 1 kilo ohms with 1 watt devices. The soldering iron is proving to solder quite nicely. Also there's 1, 2, 3, 4, 5, 6 hang on, 1, 2, 3, 4, 5, 6, 7, 8 jumper wires to install. They're just marked with a little line with a J under it. Don't install those and it won't work. I just used this 0.8 of a millimeter link wire stuff. That's what this is designed for. It's tinned wire. Can't remember how much it cost now. Anyhow, you can use the resistor cutoff leads, but with ones that are this long, I doubt you're going to have enough length on any of the cutoffs to make that connection. I'm also almost out of 1.8 millimeter solder. I do have this stuff. This is digital 1 millimeter 6040 LED lead solder. I haven't used it yet and opened it yet. It's pretty dusty. It's been around a long time. I have no idea how old this stuff is or even if it actually works, but I can just find out. Apparently. But it's I prefer working with the 0.8 to be honest. So I'm going to put that aside. Now back to these resistors. We've got 2 1Ks left over here because they're underrated for what should be there. And also, and including on the parts list, they've marked and supplied 4 5.6 ohm resistors. Now I was watching a video on this particular amplifier kit from X-Ray Tony B, and again this is where I got the idea to buy it. He had the same problem and already asked the seller. They're supposed to be 5.6K because they're marked on the board 5.6K, 5.6K. Where's the other two? 5.6K, 5.6K. So yeah, these aren't going to work. And I looked at one of these 5.6Ks up here. It actually comes off of pin 5 of this IC, which is a dual inline operational amplifier. Well, it's a dual operational amplifier, and that goes down to ground. Okay, so let me just demonstrate here what they're doing with that op amp in the circuit. Here's the basic pin out of the NE4558. Pin 5 is a positive, or the non-inverting input. Pin 6 is the negative. 7 is an out. And conversely, pin 3 is also a positive. Pin 2 is also a negative, and pin 1 is also an out. Pin 4 is the negative voltage, pin 8 is the positive voltage. Now, we've got 2 op amps. It's a dual op amp. Right, positive, negative, output, output. This would be pin 3, that's pin 2, and that's pin 1, that's pin 5, that's pin 6, that's pin 7. Now, on the one that's going to pin 5, what they've got, this is the positive input, they've got a 560 ohm resistor that is coming off of the output pin of the op amp before it, and they've also got marked on the circuit diagram a 5K6. This is actually a impedance resistor. It sets the impedance at the input of this particular op amp. Pin 6 goes back to pin 7 via a 27K resistor there. So that's the negative feedback, and according to what I can see, they're going through a 47 nanofarad capacitor and then a 560 ohm resistor. Now, in the realms of setting the gain of an op amp correctly, doing it this way around with the capacitor first instead of the resistor, yeah, it's doesn't look right, let's just say that. I haven't reversed engineered the circuit any more than that, but I know they've got an op amp stage at the front going into a second op amp stage. I'm not sure where in the realms of things the bass and treble control come into play, probably in between the two. I don't know, this is probably the output buffer stage. But anyway, the gain of this op amp is going to be, well, this is going to be R2, this is going to be R1, so that's gain equals 27,000 divided by 560. So the gain will equal, well, I can't do that in my head, 27,000 divided by 560 equals 48.2. So we'll say 48 plus 1, gain is 49. And the reason I say that this resistor here is going to be a 5K6 and not a 5.6 ohm coming between the input and the ground plane, because the other end goes to the ground plane, is because this is an impedance resistor on that input, and 5.6 ohm is going to appear basically as a dead short to the op amp. So we know that 5.6 ohm is not going to work. Maybe one day I'll fully reverse engineer the circuit. I can't be bothered at the moment. X-Ray Tony B already had the debate with the seller on that, and it indeed is supposed to be 5.6K, not 5.6 ohm. So, because I'm nearly out of my favourite 0.8 solder, I'm going to go down to the electronics store now, and I'm going to pick up some 1 watt 1K resistors. I've been to the electronics store and I've come back and I've picked up two 5% carbon 1 watt 1K resistors to put in here, and 10 of these half watt 5K6 resistors. I've probably got some of these, sorry, 8 not 10. I've got some of these in my parts bin, but can always use some more, you know, it's not that big a deal. It's only worth like, I think, $1. And some 0.7mm Duratec resin core solder, and I mistakenly said that this older roll was a 0.8 It's not, it's 0.71, so they're basically the same. In fact, if you look at the catalogue numbers here, you will see that this older roll is exactly the same catalogue number as the newer roll. Isn't that something? Except this is a much updated print. This is old. I have no idea how old this roll was. This is 60-40. It's 60% tin and 40% lead. I hate lead-free solder because I believe, and so do a lot of other people, is that it doesn't make a very good solder joint. The solder joints look dry, even though they're not, and it's also harder to melt, practically speaking. So that's why I chose that, and instead of using 1mm solder, which is quite common, like that roll I got down there, I prefer working with this smaller stuff because I find it flows better. That's just me. So anyway, getting back on, I'll install the resistors I need to, the diodes, etc., and we'll move on. Okay, I've got the power diodes installed for the full bridge rectifier. The 1 kiloohm resistors and the 2 Zenos and the 4 5K6s. Now, remember what I said in a previous video about when you're dealing with power resistors and diodes as such, to lift them off the board a little to provide a bit of a air gap there, because these two, including the Zenos here and these 1 watt resistors. Okay, so why do we choose a 1 watt Zeno and a 1 watt 1K resistor if all we're doing is powering 2 operational amplifiers? Well, it's simple, because take the fact that we have a voltage of 15 volts, for instance. We know that that's the voltage, and we have a mythical current draw of 70 mA. If we multiply 15 by 70 mA, we get a power dissipation of 1.05 watts. That's the reason why. Now, I know that the NE 4558 ICs, op-amp ICs, have around about a current draw of, we'll say, 20 mA. So there's 2 of them, so that's 40 mA. So we're coming very close to 70 mA. So that's the reason why we choose 1 watt devices. Just keep that in mind. So it's a very good idea to replace those 1/4 watt 1K resistors that go to those diodes with 1 watt devices, or at least 1/2 watt devices. And the leads on these diodes for the full bridge rectifier are that badly corroded. It made soldering them almost next to impossible. I had to take a couple of them back out and file the leads a bit with a small file in order to get the damn things to take. It was just, you know, bubbling around the joint rather than going through the lead. So anyway, I'm probably going to, maybe for today, just leave it here, because I'm getting to the stage where I'm just getting tired and frustrated, so I'll finish this off another day. It's only capacitors, the variable resistors and the 2 large electrolytics to go. I'm not liking this AC input and speaker output being right next door to each other, and the center tap is in there. You'd want to put a header on here or a screw terminal thing to connect it, but the way they've designed it, it doesn't look like you can do that. And also, I've noticed that on the circuit board here, they seem to have an L out there as well. I'm not sure what that's about. There's an R out next to it. Oh, I see what they've done here. I see what they've done here. Right, okay. The left output and the right output are off the outputs of the power amplifier, so that's where they come from. These 2 speaker left, speaker right connections over here are actually joined to that center tap point where the transformer comes in. So this is actually essentially a star earth, if you really want to look at it that way, because all the ground planes come back to a common point. So that would be the a star earth, technically. Not a good one, but it's still a star earth. So yeah, you've got the outputs of the 2 channels here, and the 0 or ground connections here. And with these STK amplifier modules, these originally were made by Sanyo. In fact, all the STK range were. They also made power regulator modules as well in the same format. Thing is, they made them back in the late 80s to early 90s, and since the late 90s, they haven't made these anymore. So Sanyo, this is a new part. Sanyo would not have had any hand in this chip at all. So this would be a Chinese knockoff. It'd probably work, but it's not the same as the Japanese counterpart. So I was thinking of putting it on a heatsink. This heatsink I was talking about, but the chip's almost the size of the heatsink. So I don't think that's going to really work out too well. It might, but I can't get those screw holes to line up between fins, or can I? Just by the looks of things. So it might work. It'll work for a test if I have to change the heatsink to a bigger one, which I probably am, because I think this is going to be way too small. I shall do so, and I'll use the heatsink for something else. But for temporarily, I bought that heatsink, which was only like about $7 or something. Basically to test this out. That was all it was for. So that's B100K. So that's the bass part. That would be the treble part. That's the balance. That's only 50K. A B50K, which is a linear, and so all these two are linear as well. This should be an A50, but it's not, it's a B50. Oh no, that's the linear part. Oh, what a shame. That is not going to work. And also, the dickheads did not supply the goddamn locking nuts and washers. You absolute pricks. So, as far as I'm concerned, I'm not going to use these crappy pots. I'll go out and spend some more money, which I don't want to do, and buy some more proper pots, because that B50K is not going to work, because it has to be a linear, a logarithmic pot on the volume, not a linear, because that's not going to work. Because they're going through a 1K. It's going into a capacitor, into the input of the power amp. So that's going between the preamp and the power amp. So a linear pot is not going to do it, because you'll have hardly anything down here, and as soon as you start increasing it, the volume will suddenly start shooting up. So yeah, this is useless. Linear is fine for tone controls, but not a volume control. I'm sorry. Why would you do that? It even says, it's marked on the damn board, 50K ohm A in brackets, and they've given me a B. Well, it is what it is. I'm the Astro 30, and if you enjoyed this video, please remember to rate, comment and subscribe below, and you can always follow me on Facebook and Twitter. The links are in the description as usual. Also, you can support me on PayPal by donating as little or as much as you want, because your donation allows me to buy stuff to play around with on the channel. And speaking of channels, check out this guy, 12 Volt Vids. He has some great content to do with electronics on his channel. Anyway, this is the Astro 30 saying see ya, have a great day.